Hello again, welcome back to day 12 of the maths questions. We're really getting through those now. So let's have a look and start with the orange questions. So let me just share my screen with you. Okay, so question 1 has got a series of different number lines. Okay, sorry, just make myself a bit bigger for you there. So we have got a number line with an arrow A, a number line with an arrow B, and we've been told, given that A plus B equals C, we have to draw an arrow pointing to C. There's a few steps here. Each of the number lines appears to be the same length with the same amount of divisions, but the numbers at the end are different. So we need to figure out what each of the little divisions or each of the little lines is worth in our number line. So let's have a look at the first one with the A on it. We have 0 at one end and 10 at the other. Now our first step is to figure out how many divisions there are or how many hops there are. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one is 10. So there we go, I've copied it out. Now, from me even counting and reading it, you might have figured out what each hop is worth. But the important thing is to figure out the process. Well, we started at 0 and we finished at 10, and it took us 10 hops. So how much was each hop worth? So you take your finished number, you split it into your number of hops to figure out how much each hop is worth. And 10 split into 10 groups is 1 per group. So this is a nice number line where each hop is just worth 1. So we're counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can figure out that arrow A is pointing to the middle hop, or if we count them, A is pointing to number 5, the 5th hop. So we have figured out that A equals 5. Okay, now on the second number line, B is also on the 5th line, it's also in the middle, but each line can't be worth 1 this time, because if it was, we would go 1, 2, 3, 4, and we'd end up at 10, but we don't, we end up at 20. So we need to think what each hop could be worth. In this case, the end number is 20, and it took 10 hops to get there. So we take our 20 and we split it into 10 groups to see how many hops is in each group. 20 divided by 10 or shared between 10 gives us 2. So we started off with a number line like this that went in hops of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now, even though it's the same length and the same number of hops, each hop is worth more because we end up at 20. So in this case, each hop is worth 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so if B is in the middle, it's this middle line here. 2, 4, 6, 8, 10. So B is worth 10. Okay, so if A is worth 5 and B is worth 10, and A plus B equals C, C must equal 15. Okay, so A was worth 5, B is worth 10, A plus B equals C, so C is 15. They were nearly there, but they didn't just ask us what C was, they asked us to draw a line or an arrow pointing to C. Now this time, our number line isn't going up to 10, and it isn't going up to 20. This time, our number line goes up to 50. Now, it's still got 10 hops. So it goes up to 50, and it still has 10 hops. So if we take our normal process of the last number, split into the number of hops, 50 split by 10 means each hop is worth 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now we know that C is 15, so how many hops do we take when counting in 5s to get to 15? So 1 hop is 5, 2 hops is 10, 3 hops is 15. So on our number line in the question, we know that our arrow C should be pointing to the 3rd hop. So let me just draw my number line out. So it's not a very good number line, but it should be pointing to the 3rd hop because we have 0, 5, 10, 15, which is C, 20, 25, 30, 35, 40, 45, 50. Okay, do have a go at making one of these at home. So this is the old tube from inside some tinfoil. But if you have kitchen roll tubes, you could make really small one or loo roll tubes. Have a go and see. Or if you've got wrapping paper, you could make a really long one. And have a go at doing what I've done and creating more than one number line type around it. So all of these have been split into 10 hops, but one ended at 10, one ended at 20, and one ended at 50. It's a really good way to practice your times table and your division. So see if you can create a few. And if you do, send some pictures to me so that I can see them. I'd love to see a really long one made out of a wrapping paper. Okay, so let's move on to question 2. So Amir has a box of 50 counters. 12 of the counters are red, 17 of the counters are blue, and the rest of the counters are yellow. So which coloured counter are there more of? So let's think about our bar models and drawing out what we know. So we know we have a box and that whole box has 50 counters in it. We know that 12 of those counters are red. We know that 17 of those counters are blue. And we know the rest are yellow. I'm going to have to use green, I don't have a yellow pen. So 50 counters, 12 red, 17 blue. How many yellow? Well, we know by now that we need to figure out what these parts are worth to figure out the gap to the whole of 50. So 12 plus 17, 2 plus 7 is 9, and 1 plus 1 is 2. So that equals 29 in total. Now to figure out how many yellow there are, it is the gap or the difference between the 29 red and blue and the 50 total. So we're going to do 50 take away 29. But I want us to count up rather than to do it in column subtraction. So we're going to start at our 29 and go to our next 10. So how many do we add to 29 to get to 30? That's right, just 1. And then how many do we add to 30 to get to 50? That's it, it's 2 hops of 10. So if we show it on a number line, we went 1 to 30 and then 10, 10 to 50. 10 plus 10 plus 1 equals 21. So we now know we have 12 red, 17 blue, and 21 yellow. So which colour are there more of? Yellow. Okay, and moving on to question 3 then. So we have Lisa here and it says, she says, when I share my stickers between me and my 4 friends, we all get 7 stickers. So how many stickers did Lisa share out in the first place? Well, let's think about this. Let's draw our bar, which shows all of our stickers. So I'm just going to label it stickers. So here's our bar, stickers. Now, how many groups do we have? So how many people? Very easy to read that question and say 4 friends, 4 people. But it is Lisa and her 4 friends. So how many people are there all together? That's right, there's going to be 5, isn't there? 1, 2, 3, 4, 5, because we've got Lisa and then friend 1, friend 2, friend 3, and friend 4. Okay. And if all of them are given 7 stickers, and they are a good friendship group, they've shared them out equally, so they have all got 7, we can now see we filled the bar. So we can do 1, 2, 3, 4, 5 lots of 7 to get our total stickers. So 5 lots of 7, or if it's easier, 7 lots of 5 gives us our original amount of stickers being 35 stickers. So just make sure you remember to include Lisa in that question because she keeps some of the stickers for herself. Okay, well done. That is day 12's orange questions done. Let's have a look at day 12's blue questions. Okay, we're back to our 3 number lines here, but they're a little bit trickier to figure out the gap. I'm afraid my tube has run out of space and isn't going to work for this one. So again, A plus B equals C, and we have to draw an arrow pointing to C. But let's have a look at this first number line, and I will copy it out onto my board so we can see. So we have got 1, and then we've got 1, 2, 3 lines, and then the 4th line is 2. And then 1, 2, 3 lines, and the 4th line is 3. So I've been giving a little bit of a clue as I was drawing it out there by counting the lines, okay? So we need to figure out again what each of these hops is worth. But instead of just going to the end of my number line, I'm going to pick to go between 2 numbers. So let's just take between 1 and 2, or we could take between 2 and 3. In each of those cases, we move 1 whole unit, don't we? So we know that each of the hops is going to be less than 1, or a decimal of 0 point something. We might be jumping in tenths, in hundredths. Let's have a look. Well, I was counting as well how many hops it takes. So it takes 1, 2, 3, 4 hops. To get from 2 to 3, it takes 4 hops. All the same here. 1, 2, 3, 4. To get from 1 to 2, it takes 4 hops. So if we are trying to divide 1 whole into 4 hops, we can think about what that might look like. It is 1 whole divided by 4. Now you will all recognise this as our fraction, a quarter. So some of you might now know straight away what the hops are worth because we've practiced knowing what our fractions are as decimals and percentages. But if we're not sure, let's think about it as each of those hops is equal, or each of those 4 hops, sorry, is equal to a whole unit. And we know that a whole unit is made up of tenths and hundredths and thousandths. So we want to think about, we've got 100 hundredths. To get from 2 to 3, we could go 2.01, 2.02, 2.03, and so on 100 times. And we want to split that 100 into 4. So I'm going to think about how many hundredths each hop will be worth if I divide 100 into its 4 hops. Have a go at doing that for me, and some of you may have remembered that an easy way to divide by 4 is to divide by 2 and then 2 again. So half of 100 is 50, and half of 50 is 25. So 1/4 is the same as 25 hundredths, which as a decimal is 0 units, and then 2 tenths and 5 hundredths, or 25 hundredths. So each jump here is worth 0.25. So now let's find where A is and let's count. So 2 plus 0.25 is 2.25, plus another 0.25, or if we notice here, being bang in the middle of 2 and 3, means this number here, A, is 2.5 because it is in the middle. Okay, so we know that A equals 2.5. Okay, now let's have a look at number line B. And we will find out from number line B that we have 10 and then 1, 2, 3, 4, 5 hops until we hit 20. 1, 2, 3, 5 hops and we hit 20. And then B is labelled as the hop after that. So this time we're going to think about the fact we're going between 10 and 20. So how many have we moved in total? That's right, the difference is 10. And how many hops did it take us to move 10? 1, 2, 3, 4, 5. So 10 split into 5 hops equals 2. Each hop is worth 2. As we can see, 12, 14, 16, 18, 20. So if we keep counting in our 2s, B, we now know, is worth 22. So A was worth 2.5, B is worth 22. So do we now know what C is worth? Well, we can add them together and figure out that C must be worth 24.5. So C is worth 24.5. Now let's have a look at this last number line we've got down the bottom here. Where is 24.5 going to go on that one? We've got 24 and then we've got 1, 2, 3, 4, 5, 6, 7, 8 hops till we get to 25. 1, 2, 3, 4, 5, 6, 7, 8 hops till we get to 25. Okay, now what do we know about 24.5? Where is it between these two numbers? Well, as we know from working out, half of a whole unit is 0.5 or 5/10, 50 hundredths. We know it needs to be in the middle. So this time, instead of working out what every hop is worth, if we know there are 8 hops, which hop will be the middle hop? So to figure out the middle, we're figuring out halfway, aren't we? So we need to figure out half of the 8. Half of 8 is 4, so I'm going to take 4 hops and see if I'm in the middle. 1, 2, 3, 4. Are we in the middle of 24 and 25? Yes, we are. So the 4th hop is where we would label C. It is 24.5 and it is in the middle. You can have a go at working out what each hop would be worth if you like. That's quite a challenge. So think about if it's 8. To get to 8, you can do divide by 2 for half, divide by 2 for a quarter, and divide by 2 again for an 1/8. Quite challenging, but let me know if you manage it. But the 4th hop is where we should be. Okay, let's have a go at blue question 2 next. So, George has a box of counters. For every 2 red counters, there are 5 blue ones. George removes 36 blue counters from the box. And there are now the same amount of red and blue counters. How many red counters are in the box at the start? Okay, this is quite a challenging question to get your head round. We want to start by writing down what we know, and we're going to think about our ratios here. So I'm going to write out a table. I'm going to write red because we've got some red counters. I'm going to write blue because we have blue counters. And I'm going to write total for how many counters would be in the box in total. Okay, now as a starting point, I can see we have 2 red counters, or for every 2 red counters, we get 5 blue counters. So if I fill out that much of my table, we have 2 red counters and 5 blue counters. How many counters must we have in total? What do we need to do with these 2 numbers? Add them together. So 2 plus 5 tells me that my total amount of counters is 7. Okay, that's great, but I don't know where to go next. Well, the next thing we are told in the question is that George removes 36 blue counters from the box. And after he has done that, the blue and the red become equal. Okay, well, at the moment, he's only got 5 counters in the box, so it's impossible for him to remove 36. What we could think about is that we need to have enough blue counters for him to be able to remove 36. So there must be more than 36 blue counters in the box. Have a go at your 5 times tables and think, if I go in lots of 5, what do I get to be bigger than 36? Well, I know that 7 lots of 5 is 35. So I need to go to the next one. 8 lots of 5 is 40. So I'm going to write 40 in here. Now, the important thing with ratios, just like fractions, if I want to increase my blue counters by 8 times, I need to also do the same to my red and also do the same to my total. So 5 times 8 was 40. So now I need to do 2 times 8, which is 16. And hopefully we'll recognize that 40 plus 16 is the same as 7 times 8 of 56. So can you see we've times all 3 of our numbers by 8. So the box has got 8 times bigger. We now have 56 counters in total, 40 blue and 16 red. Okay, but if I take 36 blue out, I'm only going to be left with 4. And 4 is definitely not the same as 16. It's far too small. So I could just keep going. I could just keep adding another lot of 2, another lot of 5, and keep going. But I don't know how long that will take. I'm now going to add another column to my table. And we're going to look at something else. We are going to look at the difference between red and blue. So the difference between red and blue. Okay, now in the first lot we had 2 red and 5 blue. Now what's the difference between 2 and 5? It is 3. Now we then times everything by 8, didn't we? So we ended up with 16 red, 40 blue and 56 in total. What is the difference between 16 and 40? Well, I'm going to count on, in fact, I'm going to do it in my head using place value this time. So we're going to partition this into 10 and 6. 40 take away 10 is 30, and 30 take away 6 is 24. Now, do we notice anything about the fact we times this by 8, and we times this by 8, and we times this by 8? What's happened to our difference? It has also got 8 times bigger. 3 times 8 is 24. So using the difference could give us a clue for this answer, because we know that we need to take 36 blue counters away, and then that needs to be blue and red being the same. So the difference between the blue and the red at the start would have been 36. So the difference is 36. Okay, so I've filled that out in my table now. Do I know anything about the numbers 3 and 36? Could I figure out how to get from here to here, or how to get back from here to here? Have a go at your 3 times table. You all know that 10 times 3 is 30. So 11 times 3 is 33. 12 times 3 is 36. So we have actually times our original number by 12. 3 times 12 to get to 36. Now, what's our rule? That if we do that to one of the columns, we have to do the same thing to all the columns. So let's do 2 times 12. 2 times 10 is 20. 2 times 2 is 4. So that will give me, or I better keep my colour matching, that will give me 24 red counters. What is 5 times 12? Well, if I do 5 times 10, that's 50. And 2 times 5 is 10. So that gives me 60 blue counters. So 24 red, 60 blue, and I can add those together to get 84. Let's just check that 7 times 12 is 84. Well, 7 times 10 is 70. 7 times 2 is 14. So yes, it is 84. Now let's just check, is this right? 24 red, 60 blue, 84 in total, the gap of 36. Well, let's have a look. If we add 6 on to 24, we get to 30. If we add 30 on to 30, we get to 60. So we do have the correct gap. So if we take 36 counters away, we would end up with 24 blue, 24 and 24. So how many red counters were there at the start? There were 24. So I know that might seem confusing, a lot of steps. Please do pause it or go back and re-watch the explanation now I've got to the answer. But it's important to start with your ratio table, red, blue, and total. And then once we've figured out that it was actually the gap that was increasing because we wanted to take away that amount, we could just add another column. Okay, nearly there for today then. So we are now going on to question 3, which says that Elijah says he divided 32 by a number and got 64. Is this possible? Have a think, pause it and try and explain it to a parent or sibling and tell me, what do you think? Is it possible to divide 32 by something and end up with 64? And whether you think yes or no, you have to be able to explain or justify your answer. Okay, well, let's think about what we normally know about division. If I start with 32 sweets and I am dividing it by an amount of people, the number is going to get smaller because I am sharing my sweets out, aren't I? But we have to remember that we work with lots of different types of number. And if I divide by something that is less than 1, I'm trying to figure out how many of that thing will fit into it, aren't I? When we share things out, we're figuring out how many fit in. So if I wanted to figure out how many of the number 1 I can fit into 32, I can fit 32 of them in, can't I? If I want to figure out how many of the number 2 I can fit into 32, I need to count in 2s now, and I'll get to the fact that 16 fit. So 1 times 32 is 32. 2 times 16 is 32. In fact, I think I could even have a go at 4s, because I believe 4 is a factor of 32. So 4s, if I count in my 4s, I'll figure out that I managed to fit 8 in to get 32. But this isn't helping me because as I go 1, 2, 4, the number gets smaller. And I know if I'm doing my division, I want to end up with 64. I want to get bigger. Remember what I said about if we start with a number less than 1. If I'm trying to divide 32 by 32, I get 1. But if I divide by something less than 1, I'll be able to fit more of them in. Have a think about that. What do we know that is less than 1? We could go into our decimals here, go between 0 and 1. Now, if we go to a half, we know that a half as a decimal is 0.5. Now, how many 0.5s fit into the number 1? Or how many halves fit into the number 1? That's right, you can get 2 of them because a half plus a half equals 1 whole unit, doesn't it? Yeah? A half plus a half equals 1 whole unit. Or, in other words, 0.5 times 2 equals 1. So if every 1 you can fit 2 0.5s, what we're saying is if you were to swap that round and do the inverse, because we know all about our factor families, if we did 1 divided by a half, it would equal 2, wouldn't it? 1, how many halves fit into 1? 2. So if we try this same concept with our 32 and do 32 divided by a half, well, we know that 32 wholes fit in, and for every whole you've got 2 0.5s. So actually we need to double our number because we can fit double the amount of halves in, can't we? So double 32 gives us 64. So this is quite a tricky question because you might think, well, no, when I divide, I get smaller, not bigger. But if you divide by less than 1, you can fit lots inside. So 32 divided by 0.5 will give you 64. So there is a possible division, but the answer is less than 1. Really well done if you managed to follow me on that one. It's quite hard to get to grips with. A really good way is to have a go at cutting things in half and then counting all of the pieces of paper it took you to get up to 32 originals. And it might make more sense if you can show it visually. It's a little bit difficult for me on these videos when I've only got the whiteboard to have a go. But well done for doing day 12. So we are cracking on. I think there's 20 days in total, so we're over halfway now. And as I say, please do have a go at these number line tubes. If you can go all the way up to 100 on a wrapping paper tube, that would be brilliant and will really help you with your maths. Thanks very much, and I'll see you soon. Bye-bye.